So I'm going to talk about Test Chado, the module I developed at DictyBase for doing unit testing with Chado database. First, so here is what in my agenda. I'll give you a little bit of background how I came to develop this module, then a little bit about Perl testing. I think not a lot of you use the Perl testing, or it's a separate language. And then how you can use it, how am I using it, and what is the advantage of using it. And then I also developed, it's called a testing pipeline, how am I using it, and then where can you get and what kind of documentation I have about it. So the background, a little bit about DictyBase. This is a mod for dictyostelic genomes for the last 12 years. The primary organism is the slime mold or Dictyostelium discardium. This is a picture of a dicty with a stalk and a little bit of head. It's composed of multiple dicty cells though. It's a social amoeba. It actually has two features. One is called cheaters and one is called altruism. So you get two different kind of cells inside this structure actually.
What other one's called cheaters?
So there are cells right inside here.
But one of them are called cheaters?
Yes.
That's
they
funny.
have a gene. It's called CHE. It's mutated and it goes away the cheating traits.
That's funny.
Yeah, it's heavily published. And there is a lot of strains with also altruism. It's found in soil and of course it feeds on bacteria. These are the genome facts. The interesting and the challenging part for me is the chromosome to inverted duplication. It was quite a handful while doing the GenBank submissions for it. The other interesting part I always find is the 17 different acting genes. All these genes code for the same identical protein. They're all active, the protein sequences are the same. And UniProt has a lot of problem handling that. So if you submit it to UniProt, you have no idea which gene it comes from. You always have to, in the software, get around about it. So now getting back to the software stack, this is the one we have right now, and that's the one I inherited when I started. And this is the part I mostly added. The main part is the Oracle instant of Chado, so we still run our Oracle version with a custom schema that we inherited from SGD almost like 12 years back. Mostly done with the Perl. We had an old version of Biomart with Oracle. The pathway tool, it goes on and off. It's an old version, and then everybody used to whenever you have Perl, Mod, Perl, Apache, Perl script. And then this is the part I added later on. It's kind of a modern stack: Mojo, Research, Plaque, FCGI, Apache. And like a year and a half back, I wanted to migrate to gbrowse too, so I basically dumped the GFF3 from Oracle, put it in a PostgreSQL instance to have a test run how it looks like when we try to migrate. So this is kind of our gbrowse stack now. We've done gbrowse too. With Oracle, we always have some issues. It's running for last 12 years. Last 6 years have different kind of issues. It requires a lot of administration for doing simple tasks. The other one is a direct conflict with Chado schema. Chado schema comes with a table called synonym. You cannot use it in Oracle. So it becomes synonym underscore, which is a pain. You cannot use, there is a column called comment in organism. You cannot use it. That basically breaks most of the Gmod tools. Like you try to use gbrowse, it breaks. So we have to customize our code to use it Oracle, and that maintaining is very hard. So Scott keeps on releasing his code. It's very difficult for us to keep on. I love testing sometimes, but with Oracle it's not so easy. It's not very Unix. You just type in a command line or install or something. It's like its own way of doing it. So what I thought so far is for a small team like us, it's not worth doing it. If you have a big team infrastructure, you have people, you use Oracle. And then it also, we figure out if we migrate to PostgreSQL, we might save some money. That's what my boss told. So that's not a bad option getting the way the grant is getting cut nowadays. This is a problem with the 12 years of code base that's hardly got refactored. We are actually stuck with a 32-bit VM for the last 6 years. We cannot even upgrade. It's 6.0 Ubuntu. Long time back. And it's very hard to write test cases for Mod Perl and Apache. If anybody work with Mod Perl and integrate into Apache and write test cases, it can be a pain, another pain. So we decided to, so this is what it looks like to me. If you look from outside, so we keep on add stack after stack, and then you cannot add anything. Just all thing falls apart. You touch it, it breaks apart. It's pretty much most of the things are slowly getting broken. It looks nice from outside. I keep on that way, but it's slowly getting broken. It's still running. So we started this, we call it the overall project, started last year. The idea is to get rid of Oracle, go to PostgreSQL, and changing a lot of stuff around, mostly retooling a lot of software stack that's mostly built around our database, to maintain our database. So, and try to do it in small pieces, like Lego pieces, and then build the whole infrastructure. And the main part I try to focus to have some kind of testing to get an idea when it's actually going to fall apart or not, what's broken or not. Testing is very good if you want to know what state you are in. I'll explain it later on. So at this point, we are at the last phase of migrating the data from the Oracle. We got most thing out of it. Just the annotation, mostly the gene ontology annotation that I'm handling now. On the way of doing that, I developed a bunch of tools with my other team member. This is the one I developed first. It's a testing framework I'm going to talk about. I also used another nice Perl tool. It's called Squitch. It's allow you to manage your change in database. And I understand that with a lot of Chado users, I'm going to apply some custom schema, or I'm going to get it from somebody else, but I want to get sync with upstream, whatever I get released. You can use Git, exactly like Git, to manage all of your schema changes. You can go back and forth, up and down, everything. Most of the backend supported, PostgreSQL is heavily supported. It's done by one of the guy who is a Perl PostgreSQL guy, who also run a PostgreSQL company. So it's pretty solid software. The other one is Modwell Loader. We are using it for a long time. It's basically a lot of export, import, command line applications. One of the things I developed using it is to fill up the CV term path. So use our tool to make a transitive closure list of, and then fill it up. It's heavily needed if you want to do work on the ontology in Chado database. And for every one of them, we try to use this testing framework I have developed. And these are under development, kind of a small HTTP backend API and the front-end API. So we are trying to break things apart now. Instead of one software directly talk to database and get the data, just in 2 layers.
What do you think the HTTP API is going to look like?
The idea is to have like kind of a RESTful look and sending out JSON.
Okay.
Seems to be the way to go. And then, I just talked to Rob yesterday, and he also has this RESTful backend for JBrowse.
Mm-hmm. Well, that's actually what made me think
that's
about it. That's why
it will be very easy for us to use JBrowse.
Yeah.
So this is the way it looks like. So this is your Chado instance in PostgreSQL. So all of our stack you see will be using test Chado to send test file to Chado and get it tested. So this is the way it looks like in a developer notebook. I'll show you how it's actually fit into the whole workflow. So I'll just go with the basic testing. How do you write a test file? Just go very quickly with it. It's called .t file, or even .pl also fine. You load your testing libraries, write your tests with your test API, and then run any of the tools commands. The testing API is very simple. It says like what you got and what you expect and whether it works or not. If it works, the whole test runs through. And Perl has a pretty decent amount of testing API, and it's very easy to read. Okay, it isn't, and then you can write your custom test also. That's what I've done most of the for test Chado. So what's difference with adding for testing backend? The main thing it's called unit testing is the setup phase. So you have to set in setup phase. What you do, you create a temporary instance of database, load your schema on it, and if you need, sometimes you need some test data on it, load it at that phase. Run your test, and then this is highly recommended to move out the database you created with all of your data and schema. But for example, if you use a SQLite database in memory or temporary, it goes out by Excel. But if you client server, something like PostgreSQL, MySQL, even Oracle, you have to write code to get rid of it or provide some kind of API. So these are the two steps actually not very easy for Oracle. You just cannot make a new database and get rid of it. It's not so easy. And being proprietary code, it's extremely difficult. So that's another place where PostgreSQL is very handy. So let's see how we can use test Chado. So the features are, it's all based on Perl toolchain. If you have any Perl distribution, it just goes right to it. It supports PostgreSQL, of course, and if you don't provide any options, it just creates its own SQLite instance and run it on there. The distributions comes with a copy of a Chado schema that it instantiates right there. So I made some modification to run it in a SQLite. There is a decent amount of testing API which is built with Perl. For Chado, you can load actually your custom data sets if you need something for testing. I'll get into it again. And you can actually run parallel testing. If you have 10, 15 tests, you can run 10, 15 tests at the same time. Perl has a built-in support. I made sure that it works that way. So how it works? So in the setup, I create a Chado database. As I told you, I put some test data on it, run all of my tests, and then boom, it's gone. So here is here I load my testing libraries. This is the standard Perl that comes with the code. These are the two libraries. And this is where everything happens. You call this method called Chado schema, load fixture, I'll explain a little bit later on. This basically instantiates a Chado schema and give you an object. It's called biochado schema. It's a tool developed by Rob Wells also. It's a nice piece of ORM written in Perl. You can write all object-oriented code at the same time. You can get a lower level handle and work on it. So it's very flexible to learn. So this is the one I use. And then these are the API I developed. For example, here it checks for a presence of a CV term, checks for a presence of CV term, UBXref, and then you have an API to drop the schema. So for example, here it checks for, you pass the schema instance, ask whether this sequence CV term is present, and then your description. The same with DBXref and CV term. And then it's pretty standard run, gives you the output. You can run with proof or the binary that comes with Perl. So here is a little example so I wrote just a small subroutine to load some gene feature in the database. It uses again the biochado schema. So here I just use the human organism instance and load the gene name that's been passed to it. So here it looks like. So you get the instance schema, create two things, and then there is another API called has feature. It checks whether that feature is present in your database, and then you run your test. Same with feature location. So this is basically given a feature and to location, it creates a feature log entry. You use, for this case, it's called has feature log. It does not test for the start and end, but it says whether you have a feature with feature location. These are the very simple thing if you want to test. So now, how to test with a PostgreSQL instance? Well, you need to have a running PG server. The way it works is, as soon as you call that method, it creates in PostgreSQL have a concept of schema namespace. In a single database, you can create multiple schemas. So it creates a temporary schema as soon as you call that method, and then load the Chado on it, and then run your test. So that's why you need to have a user that can create, read, update, and delete schema in PostgreSQL. And another advantage, if you have an existing DB, you can use it very simply because it's not going to touch your database. And then you set up a bunch of environmental variables like the entire PostgreSQL DSN, like the name, host, port, and then user and password. And it's very simple running from the command line. Just give the information and it will run the entire test with the PostgreSQL. So the same test file, don't give anything, go to SQLite. If you have PostgreSQL, it goes to PostgreSQL. You can even export all the variable and put it in a bash script. Here comes the other part. So you can even run all the tests without having a PostgreSQL server. So what are the options? So there is a company called Heroku, which actually give you development PostgreSQL database for free. Just sign up. You can show, but you can create multiple PostgreSQL databases for development. click on one of them, it basically creates a EC2 Amazon instance for you and give you username password. And then you can just pass the credential and it runs all of your testing care of you. So you don't have to install anything other than client libraries. So another gem I found, it's called Postgres. It's basically designed to run tests for PostgreSQL. It has HTTP API. One database lasts for 30 minutes. You can do 100 requests per hour per IP. Not bad. So here is the way you create it, gives you thing, and for running with test Chado, you just set it up, and test Chado will do everything for you. You create that database, load your test data, run the test, and come back with the result. It's a little bit slow because it goes to the network, but it gets your job done. Again, you don't have to install anything in your machine. Now it also comes with a bunch of extra APIs, especially testing with CV term. So this one counts CV term, this one checks for synonym, this one checks a relationship between parent and child. So these are all the things I face, so I actually turn into a testing. You can do a bunch of counts and then also a bunch of extra checkers. Of course. So, but you know, with API you can go up to a certain point. You have to ultimately use raw SQL for testing. So how do you do that? So that cpan comes to rescue. You use a module, it's a really nice module called test database raw. So what you do is basically from the schema you get a raw DBI handle. This is the flexibility of this biochar schema. And feed it right here. And then you write your SQL, use a method called row OK, and will run your test. Whatever SQL you feed, it will run it. So it gets nicely integrated with test Chado if you just want to run raw SQL. So another library. You start writing SQL, what you happen, this kind of SQL, if you put it in your program, it becomes very hard to read. Say you have 10, 15, 20, 30 SQL. So you basically put it in an INI file. Put all your SQL and use this module called SQL library. Feed it here, and then here you go. It gives back the SQL, and then you can even pass bind parameters in it. And it gets nicely integrated with test Chado. So test Chado, test database row, SQL library, that makes a really nice testing companions for you. And remember, these two tools you don't have to use with test Chado, you can use it any testing. Very generic tool, but very useful. Now about test data. So how do you load test data and why do we need it? So if you look at this typical Chado dependency, if you want to load feature, you need ontology all the time. You need organism. Say you want to load gene ontology annotation, you need feature, organism, CV. You need analysis, you need feature and CV. So basically there is always a data dependency if you want to test a particular module and you want to load data in that module. So what fixture can do? It allows you to resolve the data dependencies in a very same way. For example, if you want to load feature, you can prepare show and organism fixtures for you, which you load during the setup phase. It provides you a consistent data set to run again and again. You can actually bundle your fixture and distribute it very easily. So what I did, I picked up another really nice module called DBIS class fixture. It goes really nice with biochar schema. It has a defined spec. It's a JSON file. Just write it down like JBrowse, and it gives you where to load fixture. And then make a tarball of your fixture and release. So that's what I did. I basically bundled the default fixture with test Chado. So remember this method, as soon as you run it, this is what things it loads. It loads the default organism. If you look at the Chado distribution, there's a default YAML file. So that it loads CV property ontology, which is very important if you want to load CV and you want to specify a version. Sequence ontology, relation ontology. So this takes care of everything. So that's the way I was also testing all this feature thing. So what about you want to load your own data? Okay, so it comes with a script. It's called prepare fixture. So if you have already a database, you know the data out there, just point the script to it. It will make a nice DBIS class fixtures compatible tarball for you. And then you get that tarball and feed it to that method instead of the default fixture. And then it's inside the database, then you can run any test on it. And this I'll go through, since it's a library, you can put it in any Perl distribution you like. It's a very standard Perl makefile. I go very quickly here. Where is it? Here is it. Put up the version also. It's a build file, the one that comes with GBrowse. Here you go, test Chado right here. And then you can run very easily like this. It's integrated in it. You can run parallel testing. Here I'm actually running 6 per instance. Like so, what Perl do is as soon as you want to run parallel test, it's basically forks. Here it's making 6 forks, 1, 2, 3, 4, 5, 6 at the same time. So you give a one PostgreSQL instance, it's run all of its testing in parallel in that instance. So this is the one, it's my testing pipeline. I call it a quality control of my code. So how it works. So I told you this is our laptop system. What else it do is, as soon as I put the code on GitHub, it triggers something called continuous integration. So there is an open hosted system website called Travis CI. It goes there, run the entire test suite I have, send me an email if it fails or runs, and then as soon as it's done, it sends something called testing coverage. It's kind of holy grail of testing. You want to know how much of your code is actually tested. So everybody tries to go there, this 100%. It's very hard, but I'm even far away from there, but it's all automated. Run your code, put it in GitHub, everything runs there, and you get your email. So how it looks like in Travis CI. So continuous integration, if you have multiple people working on your software, as soon as they put the code on the repository, it triggers the entire automatic testing, and you get a report. So you know what's happening with every member of your team, what they're doing, what kind of development they're doing. So the good part here is that actually I can run my test on 6 different Perl versions, starting from 5.10 to 5.19. I don't have to do anything. So I know if somebody is running my code and what version is running, I don't have to worry about it. I really have a report ready for it. The other good part thing, if you're working on a bunch of code on GitHub, they also shows up. I work with Chris Fields on a project called Wyoming, still shows up here, you can see. And then it goes back, as soon as you have a successful build, it goes to give you a coverage. You see, this is the tool I'm using, and I have test Chado in it. See, it's not really good. It's still getting there, but I'm far away. But, it's going up. But what happens is, it tells me how much of my code is tested. And if you actually drill down to all this report, it will show which part of the code is not tested, which is tested. All if, else, block, everything, loops, everything. A detailed report, nicely looking report. So this is more or less my the testing pipeline that I run. It's all automated. So you can get the code on GitHub. I'll probably put it in CPAN very soon. If somebody is using Perl, I recommend them to use a module, a software called CPAN-. It's very easy way to install any Perl distribution. It can actually directly install from GitHub. You don't have to worry about CPAN. So, for example, this is where you get from master branch, which is always stable. This is the release I always made. Or you can actually, if you don't like it, you can just download the table from the release page. I keep on doing preview release. This is also a great feature of GitHub. You can actually make a lot of releases there. You can also put your binary up there. So I do these releases, and you can download any releases from there and just install it. So all the code I shown, it's all there, written in manual tutorials. There are free code. These are the codes also have a separate repository, and then you can run it and test it out. So one of the things there is how you test with modules. So it's there, both the tutorial and documentation. So the things to come, I'm just going to write more things like publication feature, product analysis feature, and add a little bit more API to it. The other one I'm really interested to is PGTab. So this is another system where you can, if you have like triggers, views, functions in PostgreSQL, you can actually test it with Perl. So it's called PGTab. Tab means test anything protocol. It's a kind of protocol that Perl uses for testing. Anything that understands that can run test to Perl system. So write your SQL in .s file, put it in a Perl distribution. It will run all of your SQL function testing. So now you can also test anything that's integrated in your database. That's all for today. Acknowledgement, really thankful for Gmod project for having Chado schema. I'm a big fan of it. Chado schema developer Rob Wills and whoever is maintaining. And I don't know who are these guys, but the Power Tools is pretty good. It's not as bad people think. And it's really well maintained, and Perl has a really good testing infrastructure. If you put your code in CPAN, the way it gets tested is amazing. I never knew that.
Yeah.
And then GitHub and the hosting provider that I use, hopefully I'll be using it in the future also. So thank you very much.
Yeah, thank you.
Any questions?
What specific kind of coverage does the coverage tool provide? Statement or branch or?
Statement, branch, yeah, almost. So Perl actually comes with something called covert DB. You can run a command line, so that's it's basically an HTML version of it. I haven't shown it actually, so the whole Travis thing, it runs right after that. It's like the covert DB it sends to there. And you can also basically get a tab delimited file of coverage. What would you like?
There's a lot of infrastructure here that I had no idea existed. You know, these services for stuff I had, you know, like that'll let you have a free Postgres database. And
Yeah.
that is amazing.
It's amazing, yeah.
I had no idea. And the test writing you've done is fantastic. Now I've got the problem, of course, now is that now that you've done this, I need to like use it.
Yeah, it helps. It
Yeah.
helps to have some tests.
Yeah. It does.
Hopefully that will encourage a lot of people. Okay, thank you.
Thank you.
On a more simplistic level, we use proven cover already.
Really? Oh,
Some
cool.
command line.
Oh, cool. That's pretty much.
We've got rules about testing our groups. So.
That's nice. That's nice.
But you can do a very, very, very simple proven cover on the command line as a pre-release
Mhm.
before you tab all stuff up anyway, and then you can include the reports. So cover can do HTML on the command line as well, that you can just include.
Correct. Correct.
You can just include it in your talkball so people can see the report of the coverage stats and test
Mhm.
stats and everything.
Great. All right.
I'm sorry.